trig ratios. We're talking about the ratios of different sides of a triangle, of a right triangle specifically. So first, we gotta label our sides. We gotta know what we're talking about. So here's our right triangle. Here's our right angle. Opposite the right angle is what's known as the hypotenuse. And then let's talk about our angle that they actually highlight here. This is our delta angle, but this is the angle. That's important. So if this is our angle, the one opposite of it, across from the angle, is we call that opposite. And then we have one more side, which is right here. This is what we call adjacent, which means next to, or next to that angle. So this is the one next to our angle. This is the right angle, so it has a hypotenuse. And then there's our angle that's opposite. So there we go. That's how I label the sides. Now, what are the trig ratios? We have sine. We shorten it like this. Well, of an angle. It has to be sine of something. We have cosine. Oops. Oh, I was going to write it out. Cosine. So like that. So for short, we say cosine. This, right? So sine, right, for short, it's like that. That's cosine. That's how we write for short. Write it short. And then tangent, which is written like this. And then the ratios are, sine is known as opposite over hypotenuse. So opposite over hypotenuse. So this guy over this guy. Cosine is known as adjacent over hypotenuse. Let me change these colors a little bit. And adjacent would be this one. Let's try to make these all match up real quick. There we go. Just like that. And then tangent is opposite of adjacent. So those are the three trig ratios that we can mostly use. Sine, opposite of hypotenuse. Cosine, adjacent of hypotenuse. Tangent, opposite of adjacent. So remember, it's a ratio. It's like this, whatever this value is over whatever that value is, and vice versa. An easy way for most people to remember this is SOHCAHTOA. So let's do that. So SOHCAHTOA. Like that. Right? So opposite, sine is opposite of hypotenuse. Cosine is adjacent to hypotenuse, and tan opposite over adjacent. Tan is opposite over adjacent. It's what I use to this day to memorize my trig ratios. It's just super helpful. One thing we can notice is that tan is opposite over adjacent, which is really just sine over cosine. So it's one of our trig ratios here. So tan is the same thing as sine over cosine. So that's a big trig ratio we should know also. And the reason, if you want to know why, is because if you get opposite over hypotenuse and adjacent over hypotenuse, you divide them, you get opposite over hypotenuse times the reciprocal. These cancel, you just get opposite over adjacent. So tan is sine over cosine. So those are trig ratios, but we use SOHCAHTOA to remember which one's which. And tan is sine over cosine. So let's do a couple problems real quick. For the following triangle, find sine, cosine, tan. So what I always do, I don't write this down, but in my head at least write it. Is I label the side. So here's my angle, makes this opposite. Here's a right angle, makes this hypotenuse. And then here's my adjacent, the leftover side. I always think about it as adjacent. So then sine, SOHCAHTOA. Sine is opposite over hypotenuse. So that's going to be 15 over 17. There we go. Cosine, SOHCAHTOA, so adjacent over hypotenuse. That's going to be this guy over that guy. And then tangent is TOA opposite over adjacent. So like that. The third trig ratios. Let's do another one to practice. Exact same question. It wants to find sine of theta, cosine of theta, and tan of theta. Right, so we can use SOHCAHTOA right now just to label the sides, or no, to label the trig function. Sine is opposite of hypotenuse, cosine is adjacent of hypotenuse, and tan is TOA, which is that's spelled badly, opposite of adjacent. So next, all you gotta do is label the sides. So I always start with the angle. This is my angle, so it makes this guy opposite. Then I do the right angle. That's my right angle, so it makes this hypotenuse. And then that makes this adjacent. Now, if you notice, I'm missing this side here. They don't have it, so to solve that, we just gotta do quadratic formula. Pythagorean theorem, not the quadratic formula, sorry. Pythagorean theorem. So a squared plus b squared equals c squared. C is my hypotenuse, always. That's the only thing that matters, the other two don't. So this is to be 7 squared plus 4 squared equals c squared. 49 plus 16 equals c squared. I go with that. 50, 65. And there's nothing I can do about that. 65. So now I can say with my sides. Sine is opposite 7 over hypotenuse 65. In IB, we don't care. You don't have to rationalize. That's a good answer. You're done. Cosine, SOHCAHTOA, adjacent over hypotenuse. So 4 over rad 65. And then tan is TOA, opposite over adjacent, 7 over 4. There we go. Okay, let's finish this off by doing one last question. This right angle triangle contains a 23-degree angle right there. There's a 23-degree angle. Which side is longer, PQ, so this guy, or QR? So, I mean, you can tell by looking at it, but that's not always the case. But what we do know is since this is 23 and that's 90, this right here will be, the triangle is 180, so this will be 90 minus 23. So this side's the short side. So this side's definitely longer because the angle is longer. This one's bigger. I should say angle is bigger. So this one's bigger than 23, so it makes, that's the bigger side has a longer angle. This is a small angle, it's on the smaller side. So which one's longer? PQ is longer. Hence decide whether cosine 23 or sine 23 is longer. I think they mean larger, yeah, larger. So now remember, cosine is SOHCAHTOA, adjacent over hypotenuse. Sine is opposite over hypotenuse. So the both over hypotenuse is really just about which one's bigger, the adjacent side or the opposite side. Now remember, this is my angle here, right? So that makes this side opposite side. It makes this side the adjacent side. Since they're both over hypotenuse, both for the same value, it's all about which one's bigger on top. And that would be the adjacent side's bigger. So that makes cosine the bigger one. Cosine 23 is greater than sine of 23. If they ask, because adjacent side is greater than the opposite side. So there we go with that. Is tan 23 greater than 1 or less than 1? Check your answer. So tan of 23, remember tan is TOA, so it's opposite over adjacent. Okay, so again, which one's bigger? My opposite side is smaller than my adjacent side. So, right, we figured out here. So this is going to be a small number over a bigger number. So this is going to be less than 1. Because opposite is smaller than adjacent. Right? Because opposite side is the smaller side. So you're dividing like a small number by a big number. So you get something less than 1. Anyway, that's the lesson.